Hey, Sound Engraver here. Today we're going to be adding to our percussion kit, but before we do that, I'd like to clear up something with you regarding tempo and TempoClock. So last demo on tempo, we set up this code here that established the tempo in this case to be 88 beats per minute. So I'm just going to go ahead and evaluate that. So we have our tempo clock here and a nice stream of numbers moving along down at 88 beats per minute. But let's say you wanted to change the tempo, so you wanted to reevaluate the code at, let's say, 200 beats per minute. You can see there's a bit of staggering going on between wonderful whole integers and float numbers. And shout out to Eli Fieldsteel for giving me great feedback on what's actually happening here. And if you want to refer to his comment on my video tempo, just go ahead and see that. It's wonderfully detailed, and he gives a great example and analogy on what's going on. So to be brief, SuperCollider is actually calculating both instances of TempoClock, the first instance being 88 beats per minute and the newest instance being 200 beats per minute. I was mistaken. I thought once you evaluated that using that new value, I thought the old value was gone. I thought it was no longer in SuperCollider's memory. But Eli did point out that that does exist. So to do this in a cleaner way, he suggested the method t.tempo, or the .tempo method. And adding nil to this, you can actually update the tempo clock, and thus updating the tempo in a very nice clean way. So no float numbers here. And you can change it to 60. Go ahead and watch the post window here and see that almost instantaneously it changes to the new tempo. So that is a cleaner way, and from here on I'm using this way. He also suggests that you use this stop method, t.stop, to stop the tempo. And there you have it. So let's go ahead and run this at 88 beats again. And including that variable t for tempo, we'll just go ahead and run our kick synth using pbind, that class we're already familiar with. Stops, plays. So we are good there with pbind. Let's try pbind def. You can see it's lining up with the beat down here. And so on. So I just wanted to share that with you, just to provide that clean, efficient way for doing tempo. And now let's get into some percussion. Okay, so we are going to add a snare to our percussion kit. Now, the big difference between our kick drum and our snare is not that they're different instruments, of course, but that the kick is from this synth that generates tone. It's not a real kick drum, even though it may sound like it, or near it, I should say. But this snare is actually going to be an audio file. It's not going to be a tone generated that sounds like a snare. That's probably very complicated. But this will be an audio file. And to incorporate audio in SuperCollider, there are a variety of ways, but for a single individual audio file, it's rather simple. So we're just going to go ahead and I'm going to show you my snare sample. It's going to sound like this. I believe I got that from one of Logic Pro's percussion libraries. Oh, you know what I forgot? I forgot to copy it. I meant to copy it. All right, so I'm just gonna go ahead and copy that for future use. So for an audio file, we're going to need a name. I like to use the tilde, snare. And we're going to use a UGen called buffer. And using the method read, we're going to have SuperCollider read that audio file using this path name and send it to our audio server. So server will be its location using the global variable s and path name, and that is our file that I just copied. And you can see it's already set to a string. I'm going to go ahead and evaluate that. We've got our buffer here. And using that name again and our play method, we have this. And that's not all, because we can't do much with just pressing shift return all the time. So this audio file is going to need a synth. So we will go ahead and build that right now. I'm going to be creative and call it snare. And we will use a few arguments, and some of these arguments hopefully will look familiar if you've seen my video on how to build a kick drum. We've got our attack, release, curve value 1, curve value 2, envelope, right? Our amplitude. And now I'm going to go over here and do a few new arguments. Buff and out. I usually include more arguments in this case, but for something very simple for our snare, we won't need much. We'll go ahead and add those values. So this will be for our signals envelope. Release being 1 second. The first value being 1, and the second value being -1, as we had seen in a previous envelope example. And using 1 for our amplitude, we'll need a buffer number argument. So I'm just going to say buff and out. And because it's so short, I'm just going to go ahead and do that. For the buffer number, you can default it at 0, but I'm going to use it for a very specific thing later on. So I'm just going to leave it as is, and our out will be 0. So that looks good for our arguments. For our variables, we're just going to add a signal and an envelope. We'll start with envelope, and using this here, our levels, going from 0 to 1 back down to 0 in the span of our attack and release, and our curve values to give it that nice slope, right? Do you remember that? And using our done action message, value 2, once that envelope is done, the synth will free itself, and this will be particularly handy when doing percussion over and over again using pbind or pbind def. All right, so for our signal, we're going to include a new UGen called PlayBuf. And that is simply defined as a sample playback oscillator. Using audio rate, we're just going to use 2 of the arguments here, our number of channels and our buffer argument. These are all quite important, but I will just refrain from getting into the details there. Please also refer to Eli's tutorial number 8, I think it is, and I'll be sure to include that in the description. He goes into detail on buffers, and in particular PlayBuf and another one called buff read. So that is very handy. So for PlayBuf, the number of channels depends on whether it's a stereo file or a mono file. So in this case, our snare sample is stereo, so I'm going to use 2, and our buff argument there, and using our signal with the envelope and our out UGen. That should be good. All right, so we're just gonna give it a global variable y for our synth def, just to make sure it's, oop, not synth. Sometimes I do that. Yes, we are good. So I'm gonna go ahead and copy this pbind and pbind def that we had set up for our kick, and we are just gonna go ahead and change a few things. So instead of my kick, I'm gonna call it my snare. And our snare synth is called snare. I like to keep it simple. And we will not need this higher frequency. And we will also need our buff argument using our name. And that should be fine. Let's try that. Just gonna go ahead and give it a longer release. Same thing here. So in this case, it's gonna be my snare, snare, no high frequency, a little bit longer release, and our buffer number, which I have it as the name snare. That should be good. All right, I think that is defaulted at 60 beats per minute. So what I'm going to do is just establish our tempo clock. And I'm just gonna go ahead and copy this and put it here. We'll do it at 88 beats per minute. I'm just gonna go ahead and put that there. And now we should have a faster snare. Yeah. All right, and let's just stick with pbind in this case. So our pbind for our kick. Let's see. Let's get this all nice and organized. I like my kick at the top. Probably in my digital audio workstation too. All right, so we have it at 88 beats per minute. This all looks pretty good. We're gonna have it established at T, so we should hear the kick like this. Oh, that happens when I don't evaluate the kick synth. So let's go ahead and do that. All right. We're good. Don't let this scare you. It's just saying, hey, this synth doesn't exist. It does exist. SuperCollider, it does. So let's go ahead and do that now. We should be fine. I do think I stopped. I did a hard stop there. Okay, we're good. We're good. Okay. All right. And our pbinds, I'm just gonna clean that up a little bit. We won't need that for now. And I'm gonna go ahead and give it every other beat. Almost, right? Not quite. And this is where quantization will be very handy. And it's quite simple to implement. So I just go ahead and go T comma quant. And you can do it for right on the beat right there. Or if you want to quantize it a little bit later, you can include a value. So what I like to do for kick is do quant 4. And what that does is it's going to quantize to the next multiple number 4. So right here, 108 will be, if I put it right there, the next would be 112 and so on. So let's try it this way. So let's see, right at 130, I'm going to do it. Oh, did it at 32. Okay, that's fine. It's quantized. It's quantized. And now I'm going to do every second multiple of 2. The next multiple of 2 for snare there. Every other beat. So hopefully it will go like that. Yeah. Nice. So quite basic. And stopping our tempo clock with T-stop. So fairly basic, but once you have certain values down and quantization and a nice clean tempo setup, you should be good. So we're just going to be adding on to this and maybe adding a few things to our snare synth def in the future to add some sonic textures to our snare, as well as having a regular snare, a regular kick, a regular side snare, that's what that is. Those instruments being normal, and then just including some other lighter percussion in the future. So again, thank you for watching. Thank you for listening. And be sure to look at the description in these videos, because I refer to videos that have inspired this code. So hopefully this has been helpful. Hopefully this is going to get you started in getting some sound files, some audio files here, as you see here, and start building some percussion. So more to come in the following weeks for our percussion kit. Thank you for watching.